Okay, let's begin. Actually, I should check. Do we have sound? Record. Yes, we do have sound. Okay, we're good to go. Derivatives now. So 54 f dash x would equal the limit as h goes to 0 of f of x plus h minus f of x all over h. So that's equal to 0. 55 f dash x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. That's equal to the limit as h goes to 0. The 2's cancel. The minus 3x and the plus 3x cancels. You're just left with minus 3h over h, which will be minus 3. 56. F dash x is the limit as h tends to 0 of f of x plus h minus f of x all over h. So again, that when it multiplies out will cancel with that. That will cancel with that. The h's will cancel and you'll just be left with 2 over 7. 57. So that would be f dash x is the limit as h tends to 0 of f of x plus h minus f of x all over h. So that's the limit as h tends to 0 of 4x squared plus 8xh plus 4h squared minus 4x squared all over h. And they cancel. That cancels with that. And that ends up being just 8x in the end. 8x plus 0. Okay. 58. F dash x equals the limit as h tends to 0. 5x plus h minus x plus h squared minus 5x plus x squared all over h. So that would be 5x plus 5h minus x squared minus 2xh minus h squared minus 5x plus x squared all over h. Cancel, 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 cancel. The h and the square cancel. So you'll just be left here with a 5 minus 2x. That's 58. Okay, good, good. Let's clear this up and look at the next one. 59. 59. F dash x equals the limit as h tends to 0 of root 2x plus h minus root 2x all over h. I'll multiply above and below by root 2x plus h plus root 2x, and the same on the bottom, 2x plus h minus root 2x. So that will equal the limit as h goes to 0 of 2x plus h minus 2x all over root 2x plus h minus root 2x. So that's the limit as h goes to 0. The 2x's cancel. So you're just left with a h on the top, which I don't like, over root oh, you know what? I forgot my h here. There's actually a h here I forgot to carry down. So that would cancel the h that's left on the top. 2x plus 2h minus root 2x. Yes, okay. And why did I write a minus here? I'm being very careless. That's a plus. They have to be the same. Very, very careless. And then h goes to 0, so that becomes 2 over 2 root 2x, or in other words, 1 over root 2x. Yeah. Okay, actually, you know what? We have the answers at the back. We can be checking as we go along. So this is 54. No, it's not. It's 59. Yeah, it's right. Okay. 60 now. Very similar. Limit as h tends to 0. Root x plus h minus 6 minus root x minus 6 all over h, but I'll multiply above and below by the conjugate. X plus h minus 6 minus root x minus 6 times root x plus h minus 6. The conjugate would be a plus, actually, plus root x minus 6. So on the top, I'll be left with x plus h minus 6 minus minus 6. So the x's will cancel, the 6 will cancel, and the h will cancel down below. So you're just left with 1 over root x plus h minus 6 plus x minus 6. So that'll be 1 over 2 root x minus 6. Yeah. Okay, 61. 61. No. So f dash x is the limit as h tends to 0 of root oh no, sorry, 61, it's this one here, 9 over x plus h minus 9 over x all over h, which is the limit as h goes to 0 of 9x minus 9x minus 9h all over x times x plus h times h. So they cancel, the h cancels, and you're left with minus 9 over x squared then, or 61. 62, that's going to be f dash x equals the limit as h tends to 0 of x plus h minus 1 over, plus 1 over x plus h minus x minus 1 over x all over h. Well, that's convenient that the x's cancel. And we'll get here the limit as h goes to 0. So I've got a stray h here. I'm going to leave it out and then put these together. So that will be x times x plus h. And then that'll be x minus h. So the x's cancel out, and that conveniently cancels with the h as well. So that's just going to leave limit as h goes to 0 of 1 minus 1 over x times x plus h, which will be 1 minus 1 over x squared. Yeah, okay. And then the last one, 63, f dash x will be the limit as h goes to 0 of f of x plus h minus f of x all over h. Let's put these together, see what happens. So that's going to be root x plus h, and then root x minus root x plus h all over h. I forgot to write my limit. Sorry, went a bit off radar there. Okay, and then should I multiply by the conjugate? Let's give it a go. See what happens. Multiply by the conjugate. So that's going to be limit as h tends to 0. It'll be x minus h all over h root x plus h times root x plus h. That looks okay to me because they cancel out and that cancels with that. And so when h goes to 0, I'd be left with minus 1 over root x plus root x. So that would be minus 1 over x times 2 root x. So that would be, now you could write this as a power minus 1 over 2 x root x. If you wanted to write that as a power, that would be minus a half x power minus 3 over 2, if you wanted it like that. Yeah, I wonder how they put it at the back. Oh, interestingly, they put it as a power, but not a negative power. That's funny. That's really funny. I wouldn't have guessed they would have done that. Okay, because if you're going to put it as a power, why not put it on the top with a negative power? It's kind of, I find that funny. Okay, let's see how we're doing for time. Okay, what's next now? Let's see. For the following exercise, use the graph to sketch the graph of its derivative. Okay, let's clear this off. Okay, so we want to sketch the graph of the derivative. So 64. Okay. Right, it's going to be a very crude sketch. The derivative is the slope. So I like here when the slope is 0, so I know that's going to be there, and then I want to match it up there. There's the two places at 0. It's a negative slope here, and then positive slope. Hang on, negative slope. So it'll be under. Then it's 0. Here, just 0 there. Okay, we'll just clean that up a little bit, make it a little bit more accurate. Okay, so at those points, okay, so negative slope, 0, positive slope, 0, negative slope. So negative, positive, negative. It's going to be a quadratic like this. That's the shape you're going to get. Quadratic. Yeah. Okay, now let's have a look at 65. That's a bit tougher of a one. Pop that in. And then we might as well put the other ones in. Okay. 65, 66, 66. Oh, will it fit? And 67. Just about. Okay. All right. Get these drawn. Oh, I was writing dy dx. I don't know if that notation is in the book yet. Maybe I should switch it to the more familiar one, f dash, just in case. Okay. Right, so just repeat the process. I like starting where it's 0. So in this graph here, it's 0 definitely here. Where else now? Definitely here. That's it, just the 2. And here it's negative. Quite a bit flat here. Negative again. Positive here. So we can expect an uptick at the end, but it's negative all the way, so negative, quite negative, then approaches 0, gets quite negative again, and approaches 0. So I'm picturing, and then here it switches from being concave to convex, so kind of picturing something maybe like this. Now, the good thing is we have an answer at the back. We can check for that one. So let's see how well we did. Not too bad, huh? Not too bad. Okay. Got the right shape. That's what I just care about right now. 0, 0, and 0. So like that's about here, here, and here. Positive, negative, positive, negative. So positive, negative, 0, positive, 0, negative, positive, hits the 0, goes negative, hits the 0, positive to here, and goes negative again. I think that's okay. And then the last one here, 0 here, and then this one is positive and negative, but it's not a straight line like this, because this isn't quite quadratic. It's kind of approaching 0 again here, so I feel like we kind of wanted like a shape like this, kind of. Let's see how good or bad that is. I guess it is 0 here then, yeah. Oh yeah, sorry, I screwed that up. Sorry, so yeah, okay. Let's say that is 0. Yeah, that is 0, sorry. That is 0. Yeah, okay, so positive, negative. Okay, it's a cubic. Yeah. Okay. Yeah, okay, fine. I made a bit of a mess on the last one, but oh well. The rest are pretty solid, I think. The only one is sketch. I'm not putting the, I don't know if I, for a sketch, if they're expecting the student to put numbers in here. I just think they really care about getting the shape right. I made a bit of a mess on the last one. Okay. Oh, interesting. They want you to work backwards. What was the original function? Okay, well yeah, okay, that's funny. That some of those might make you think. I can kind of see it. This one is x power 2/3 at 1. The a is 2 here. A is 2, a is 3, a is 0. No, I know. No, that's a fun. I know that one. I got to work with that one. Okay, well we gotta. Ooh, it's another big exercise. Okay, okay. Well, we've done enough for today. So we'll wrap it up there. Thanks for watching, and I'll see you all next time.